शॉप करना था, शॉप करने के लिए नहीं चल रही है स्पीड सही नहीं आ रही।
Bismillahirrahmanirrahim. Assalamu alaikum students. Our today's lecture will be again the continuation of the previous TQM tools, and today we will particularly discuss about the implication of the quality tools, and we will discuss some practical scenarios and some real life problems that how the different TQM tools we were talking about, that is again check sheets, scatter diagrams, cause and effect diagrams, Pareto charts, flow charts, histograms, and statistical process control. All of these techniques can be contributed towards problem solving and towards the better decision making on the part of that operations managers. So today we will discuss these important problems in the problem solving perspective and decision making perspective, that how these can be helpful to solve the practical problems faced by the operations managers. Let's take an example. Suppose this is a diagram which is showing the histogram about the heights distribution of 30 people. Now suppose your marketing manager is interested to get the data about the heights of the organizational customers in order for any purpose, for any marketing purpose or for any other purpose, and suppose he is able to conduct the survey and he has the data of 30 people. Now that data is usually in the raw form, and we cannot take a particular decision, or sometimes it is difficult to take any sort of decision on the basis of that raw data. Now what should we do? That we should arrange that data in a particular classes, and then we can draw a sort of histogram by taking that variable of interest on x-axis. In this particular case, our variable of interest is what? That is heights, that is on the x-axis, and the other interest is of the frequency of all of these variables. So our variable of interest in this case is heights, which is taken on x-axis, and we are interested to draw the frequencies for the different heights. We can make the different class intervals. In this case, that is from 139.5 to 149.5, and this diagram shows that there are 6 people who have the height of 139.5 centimeter to 149.5 centimeter. Again, the next class sizes and class interval is 149.5 to 159.5, and again the frequency for this particular class interval is 9. What is meant by that? There are the 9 people who have the heights in between the 149.5 and 159.5. So accordingly, we can draw the frequencies for the different class intervals. Now suppose we want to have the idea that how many people have the heights between 159.5 and 169.5 centimeter. Now again, from have a view over this graph, we can have the idea that this is the limit of 159.5 and this is the limit of 169.5. So there are 7 people. Okay, we are interested between the limits of 159.5 and 169.5. Again, there are the 7 people who are who lie within that limits, required limits. Then if you are interested to find out that how many people have the heights less than 159.5 centimeter, so again this is the limit of 159.5 centimeter, and there are the 9 peoples plus 6 peoples, that is 15 peoples who have the height less than of that 159.5 centimeter. Then again, how many people have heights more than 169.5 centimeter? Now this is the graph for the 169.5 centimeter. So the people who have the heights of more than 169.5 centimeter is 5 people plus 2 people plus 1 people, that is the 8 people who have the heights of more than 169.5 centimeter. Then again, if you are interested in some percentage of people who have the heights between 149.5 and 179.5, now what should we do? We should add the frequency in between these intervals. Then we will divide this frequency by the total sample size. In this case, that is the 30 people, and then we will multiply it by 100. Then we will be able to get the percentage of the people who have the heights between 149.5 and 179.5 centimeter. Okay, class, why we are discussing all these sort of the limits and these sort of the things in the with respect of that histogram? Because this histogram is a sort of picture and is a sort of graphs which gives you the idea that what particular decision you should make. You know that for the marketing managers and the operation managers, sometimes it is very important to have a sort of this diagram and this sort of this arranged data so that they can quickly take some important decisions regarding marketing, regarding operations, and regarding some other thing. So important is that histogram. So these are the answers of our requirements in this particular case of histogram. So class, you may have the idea that how this simple sort of, they are not again a rocket science in making this diagram, but sometimes it can be so helpful for the operation managers to take some important decisions. Okay, let's take another example of histogram. The histogram below shows the efficiency level in miles per gallons of 110 cars. Again, a car manufacturing company is interested to find out the efficiency level of their cars, and they conducted a survey in order to get this sort of data. And so now suppose they are interested in some questions like how many cars have an efficiency between 15 and 20 miles per gallon, and how many cars have an efficiency more than 20 miles per gallon. Now on the basis of again that raw data, sometimes it is very difficult to take some important decision. So what should we do? We should arrange that data, or we can arrange that data in the form of again histogram. In this case, again our variable of interest is miles per gallon, which can be taken on x-axis, and again on the y-axis is frequency, and there is a general tradition to take the frequency on the y-axis, otherwise it doesn't have any difference. Now again class, if you are interested to take some important decisions, or the car manufacturing operation manager is interested to find out that how many cars have an efficiency between 15 and 20 miles per gallon. So if we arrange the data in the again by dividing our data in the form of some intervals, and you can in this case these intervals are 5 to 10, 10 to 15, 15 to 20, and 20 to 25, 25 to 30 miles per gallon. And on the y-axis again is the frequency of this variable of interest. Now from this diagram we can have the idea that can solve the problem of that car manufacturing company, and going through this diagram we can have the idea that what is the efficiency of the cars between 15 and 20 miles per gallon. Now this is the data, 15 to 20 miles per gallon, and what is the frequency? That is the 35. It means that there are 35 cars who have been able to achieve the efficiency level of that 15 and 20 miles per gallon. Now again, how many cars have an efficiency more than 20 miles per gallon? Now this is the frequency for 20 gallon, and this is again the frequency of 25 and onward. So we are interested in the frequency of more than 20, so we will add this 25 plus this 20, that is 45. So there are 45 cars who have the efficiency of that miles per gallon more than 25. Then what percentage of cars have an efficiency less than 20 miles per gallon? So this is the data for the efficiency level of less than 20. In this particular case we will add these frequencies, that is 35 plus 20 plus 15. We will divide this whole sum by the total sample size, because we are interested in the percentage. So we will divide it this sum of frequencies with the sample size, that is 110, and then we will multiply it by 100. So we will get the percentage of the cars which have an efficiency less than 20 miles per gallon. Now again, this is the answers for these particular questions. So you see, class, that this data is so useful to take some important decisions, and the operation managers, on the basis of this particular data and histogram, should take some decisions that how they can improve the efficiency of the cars which are not within the prescribed limits. So after this sort of presentation and after this sort of exercise, it may be difficult for the operations managers to take some important decisions regarding the quality management. So important is the practical part of these so simple diagrams. Okay class, let's take another very important example, that is the Pareto chart. Now this is again a solved example for your own textbook. Let's go through this example. The Hard Rock Hotel has just collected the data from 75 complaint calls to the general manager during the month of October. So this is the data related to the complaints of the customers. And again, you must remember, when we were talking about the quality functions and we were talking about the factors which can directly affect the quality, we talked about the complaints, that if we are able to maintain or to deal with the complaints of the customers timely, efficiently and effectively, then we will be able to maintain the quality for our products and services. So important is to give the timely response to the customer complaints. So suppose some manager is interested to go through these sort of complaints, and the manager wants to prepare an analysis of the complaints. The data provided are room service 54. It means there are 54 complaints about room service on the part of their customers. Then check-in delays 12 complaints. Are the pool is open 4 complaints. Minibar prices related complaints, that is 3, and miscellaneous complaints other than these factors are 2. So again, this is a sort of raw data. This is just the example of a simple company which has 75 complaint cells, and you must know that the different organization have the different complaint box for their customers, so that they can have the complaints from their customers and they can take the particular decision in order to deal with these complaints. But when we go through the data of that complaints, then sometimes again we may not be able to take some important decision, because that complaints or that data is generally in the raw form. So what we can do in this particular case, we can use that Pareto chart analysis technique in order to take some important decision. Now there are some steps involved in analyzing this sort of situation, and to draw that Pareto chart, the first step is we should have the frequencies which are already given in this particular case. The second step is we should arrange the frequency in the descending order. That is, the complaints with the highest frequency should become first, then the complaints with less frequency should come next, and so on. So we should arrange the frequency in the descending order. Then the next step is we should calculate the cumulative frequency, that we will going on adding the different frequencies that were previously arranged in the descending order. And then what's happened, that we will draw a bar diagram first for the frequency which was arranged in descending order, and then we will have the sort of line diagram for the cumulative frequency. So let's see how it happens. Now this is the table. Now what happens in this table, these are the in this column, these are the different complaint descriptions, which of course can be got through some survey in this particular exercise. Now this is the frequency of this particular complaints. Now what should we do? We should arrange this frequency in the descending order. Now class, in this particular case, these frequencies are already in the descending order. Now suppose if this frequency is not in the descending order, then we'll have to arrange this frequency in the descending order, and accordingly we will have to arrange this complaint description against the relevant frequency, of course. Then the next step is we will compute that cumulative frequency. That is, we will add 54 to, first frequency will remain the same, that is 54. We will add 54 to 12, 66, 66 plus 4, 70, 70 plus 3, 73, 73 plus 2, 75. So we will arrange that cumulative frequency. Then if we are interested, not always necessary, we can find out the frequency of the percentage, that is the 54 divided by the total complaints, that is in this case, particular case is 75 multiplied by 100. In this case, in this way we can get the percentage of a particular complaint. It means there are 72% complaints which are related to the room service.